Okay, and the next couple of sections, actually I believe it's 4 or 5 sections, we're going to be talking about area of different shapes. So I went ahead and combined 11-1 and 11-2. So we're going to start off with parallelograms and triangles. Okay, so in our parallelogram, the height is drawn from the base to the other base. Technically, there are 2 bases, and it is drawn to create a 90-degree angle, just like an altitude. So the area of a parallelogram is found just by taking the base times the height, just like we would do in a standard quadrilateral. Okay, so area equals base times height. So let's make an example problem of this. Let's say that this base is 21 centimeters. Let's say that the sides are 17 centimeters. And we're going to say that we're going to have a, well, let's draw in this height right here. And let's say that I give you this as 8 centimeters. Okay. So I know this is 17. So I need to find the height, which we'll just let it represent h. So I've got a right triangle there. So I'm going to do Pythagorean theorem to find out what the missing side is. And so in this case, it's going to be h squared plus 8 squared equals 17 squared. That gives me h squared plus 64 equals 17 squared, which is 289. Subtract the 64. And they've given us a nice easy one there. That's going to be 225. Square both sides. So the square root of 225 is 15. So my height is 15. They're going to ask us a couple things. They're going to ask us to find perimeter, and they're going to ask us to find area. So perimeter, we're just going to add everything together. We've got 21 times 2, which is 42. And then we've got 17 times 2, which is 34. So that's going to give us a perimeter of 76 centimeters. And now for our area, we're just going to take our base, which is 21, times our height, which is 15. And that gives us an area of 315, let's see, 315 centimeters squared. Okay, so area 315 centimeters squared, perimeter 76 centimeters. So let's go on to triangles. Okay, so for triangles we can write it 2 different ways, and unfortunately the handwriting recognition is not good on this one, so I just left it regular handwriting. We've got area equals 1/2 the base times the height, or you can represent that base times height divided by 2. Okay, so we're going to look at this example. We've got a base of 29. We need to find the height. So again, this is going to be Pythagorean theorem. So that's going to be h squared plus 6 squared equals 13 squared. That's going to be h squared plus 36 equals 169. Subtract the 36. And so now we have h squared equals 133. So that's going to give me a height of approximately 11.5. So I'm going to take my 11.5 times 29, and then I'm going to divide that by 2, giving me an area of approximately 167.2 square feet, 167.2 square feet. So if I took that height of 11.5, I could also find the perimeter of this by now using those as a squared and b squared, finding the hypotenuse, and then adding all those together, which you may be asked to do. So be ready for that. Okay, so now let's move on to 11-2, which is going to give us area of trapezoids, rhombi, and kites. All right, so in our trapezoid, we have 1/2 of the height times base 1 plus base 2. Now, it doesn't matter which one you consider base 1 or base 2. You could put the bottom one as B1 or the top one as B2. It doesn't make any difference. Excuse me. So let's get into an application problem with this. Let's go with, let's say that this has a base 1 of 12 and a base 2 of 16. Let's go in inches in this case. Let's say it had a height of 8 inches. So plugging that in, that's going to be area is 1/2 of the height, which is 8, times base 1 plus base 2. So 1/2 of 8 is going to give me 4. So area is 4 times 12 plus 16, which is going to be 28 in this case. And so that's going to give me an area of 112 inches squared. All right, so that's trapezoids. Let's move on to rhombi, or two rhombuses, depending on how you would like to say that. All right, so let's look at a rhombi, and just to let you know that we're going to use the same formula for rhombi and kite, because if you turned a rhombi sideways, it would kind of look like a kite. It wouldn't kind of look like one, it would. And so the area for a rhombi and a kite is going to be 1/2 of diagonal 1 times diagonal 2. Or you can take diagonal 1 times diagonal 2 and divide it by 2, however you would like to do that. Okay, so let's go back into our rhombus knowledge, and let's say that this is 7 feet, and that's just that little piece, and this is 9 feet. If we remember the properties of a rhombus, the diagonals are perpendicular, and they also bisect each other. So I know that this is 9 feet, and I know that this is 7 feet. So that makes diagonal 1 equal to 18 feet. That makes diagonal 2 equal to 14 feet. And so I'm going to take those and multiply them together and divide by 2. And that gives me 126, and this is feet, so it's going to be feet squared. So the key in this section is going to be keeping your formula straight and what do we use on what shape. So I'm going to go ahead and just go back in here, and I'm just going to write and kites. See if I can get this to recognize. Perfect. Okay, because they're going to have the exact same formula. Okay, so that is 11-1 and 11-2 in about 9.5 minutes.